In this video, we are going to learn how to find rates of change by differentiation. Let's start with an example. Suppose the temperature of an object is a function of t, where t is the time measured in seconds, and the temperature is measured in degrees Celsius. And suppose Ft is equal to t squared plus 10. Then we can draw a table like this, and this table shows how the temperature changes with the time taken. Now let's think about this question. What is the rate of change of the temperature of this object from t equals 1 to t equals 5? To answer this question, first of all we should know the meaning of the rate of change of a quantity. The rate of change means the change per unit time. That means in this example, the rate of change of the temperature from t equals 1 to t equals 5 is equal to 24 degrees Celsius over 4 seconds. 24 degrees Celsius is the change in temperature, and 4 seconds is the change in time. As a result, the rate of change of the temperature is 6 degrees Celsius per second. In this example, when we are talking about the rate of change of the temperature, we are referring to a certain period. And when we are doing our calculation, we are going to find the change in the temperature over this period of time. And this concept is known as the average rate of change of a quantity. For the average rate of change, usually when we consider a different period of time, then the rate will be different, just like this. From 1 to 4, the rate is 5. From 1 to 3, the rate is 4. From 1 to 2, the rate is 3. That means we can see that in this example, the rate should be changing with the time itself. And if we can have this period getting closer and closer to 0, then we are getting the rate of change at that particular instant. On the other hand, we know that we cannot consider the rate from 1 to 1 because we cannot divide something by 0. Instead, we can consider the limit as the period of time approaches 0. This limit is exactly equal to dft dt. That means the derivative of this function with respect to time. And when we differentiate this, we can get that it is equal to 2t degrees Celsius per second. Therefore, we can get that the rate is equal to 2 degrees Celsius per second when t is equal to 1. And that's the rate of change of the temperature, not from 1 to 1, but at t equals 1. As we can see, when we talk about the rate of change of something, it is not necessary to refer to a period of time. We can also refer to an instant. And this concept of rate of change is called the instantaneous rate of change. In this video, when we talk about the rate of change, we are automatically referring to the instantaneous rate of change. From this example, we know that the rate of change of a quantity, let's say it is x, is equal to dx dt, where t is the time. In other words, when we want to find the rate of change of a quantity, we just need to differentiate this with respect to time. Now let's take a look at two examples and see how we can find the rate of change by differentiation. In the first example, we know that the rate of inflation of a spherical balloon is 0.5 meter cubed per second. So what should be the rate of change of its radius and surface area when the radius is 1.5 meters? First of all, we can let v meter cubed, a meter square, and r meters be its volume, surface area, and radius respectively at time t seconds. From the question, we know that the rate of change of the volume is 0.5 meter cubed per second. So we should start with the volume, and we know that the volume is equal to 4 over 3 pi r cubed. On the other hand, we know that r is equal to 1.5, and we want to find the rate of change of radius. That means dr dt. Please pay attention that we should not substitute r equals 1.5 in this equation before we do differentiation, because when we're doing differentiation, we assume that everything is changing. If we already substitute r to be 1.5, then we have assumed that r is a constant, so we should not do that. That means after this step, we should not do substitution. Instead, we should do differentiation with respect to time. However, the right-hand side of the formula is not in terms of t, so in order to do this differentiation, we should consider the chain rule like this. And now the result is equal to 4 pi r squared times dr dt. After differentiation, we can do substitution. Now we know that dv dt is equal to 0.5 and r is equal to 1.5. So after substitution, we can solve that dr dt is equal to 1 over 18 pi. dr dt means the rate of change of r. Therefore, we can already conclude that the rate of change of its radius is 1 over 18 pi, and the unit is meter per second. Next, we should find the rate of change of the surface area. That means we should find dA dt. And we know that there is a formula telling us that A is equal to 4 pi r squared. Now we can try to find dA dt by chain rule, and it is equal to 8 pi r times dr dt. We already know that r is equal to 1.5 and dr dt is equal to 1 over 18 pi. Therefore, we can find that dA dt should be equal to 2 over 3. As a result, we can conclude that the rate of change of its surface area is 2 over 3 and the unit is meter squared per second. Finally, let's take a look at this example. In the figure, water is dripping down from the tip of an inverted conical funnel at the rate of 4 cm3 per second. The base radius of the funnel is 15 cm and the height is 25 cm. What is the rate of change of the water level when the water is 15 cm deep? Now let's analyze this question a bit before we work on the solution. In the figure, h is the water level. So in this question, to find the rate of change of water level, that means we want to find dH dt. For convenience, we can let V cm3 be the volume of water and T seconds be the time. From the question, we know that water is dripping down at a rate of 4 cm3 per second. Therefore, we should know that dV dt is equal to minus 4. Minus means V is decreasing. On the other hand, from the question, we also know that the water level is 15 cm deep. That means H is equal to 15. That means now we want to find dH dt when H is equal to 15 and dV dt is equal to minus 4. In order to find dH dt, we should first of all find the relationship between V and H. And there is a formula telling us that V is equal to 1/3 pi r squared H, which is the volume of this cone. In this formula, there are 3 variables, V, R, and H. But we know that we should only consider 2 variables, V and H. So we should rewrite R in terms of H, because R is changing with H. By considering similar triangles, we should know that R is equal to 15 over 25 times H. Please pay attention that at this stage, we should not substitute any number into the formula, because we are going to do differentiation. If we do substitution before we do differentiation, then we already assume that this is a constant, but actually it is not, it is a variable, it is changing. So we must do substitution after we do differentiation. Now we already obtained a formula in terms of V and H, and now we can find dV dt by considering the chain rule, and it is the result. After differentiation, we can finally do substitution. We can substitute dV dt to be minus 4 and H to be 15. As a result, we can solve that dH dt is equal to minus 4 over 81 pi. Therefore, we can conclude that the required rate of change is minus 4 over 81 pi cm per second. The minus sign here means the water level is decreasing. To conclude, in this video, we have learned how to find the instantaneous rate of change of a quantity. To find this rate of change, we can simply do differentiation, but we should pay attention that we must do numeric substitution after differentiation, but not before differentiation.